Hi, this is Dr. Roji. In this video, we'll see how a Boolean function can be simplified. So in the previous lectures, we saw how a Boolean expression can be formed, what are the types of Boolean expressions, etc. A quick recap, a Boolean expression can be either in the sum of products form or the product of sums form. Initially, we formed the truth table based on the problem given. Once the truth table is formed, we extract either the sum of products or the product of sums expression from the truth table. So to get the sum of products expression, we choose all rows which have 1 as the output. Vice versa, to get the product of sums expression, we choose all rows which have 0 as the output. Now, formation is not enough. We have to simplify because we are in the era of miniaturization. To simplify a Boolean expression, we have a method which involves Boolean laws. We have the tabulation method, which is called the Coin-Maclaurin key, and we have the Karnaugh Map method. The Karnaugh Map method is widely used. So in this lecture, we'll see the various aspects of Karnaugh maps, the rules involved, and how a simplification can be done using the Karnaugh map. Yeah. So in this video, we'll see how a Boolean expression can be simplified by using Karnaugh map, right? So before going into the actual lecture, I'll see what is the overview of this lecture. So first we'll see how a Karnaugh map can be formed. The types of the Karnaugh map, formation of a group inside a Karnaugh map, naming a group, obtaining the simplified expression from a Karnaugh map, sum of products and product of sums, and finally implementation using gates, right? So this expression, right, has this truth table. So to obtain a truth table, you should have a clear idea on decimal to binary. So I'll just explain it and then we'll go into the truth table. For example, I'll give a problem: convert decimal number 37 to binary. So decimal to binary conversion, as you all know, is done by repeated division by 2. So 37 divided by 2 is 18 with a remainder of 1. I'll again divide 2, 9 with the remainder of 0, 2, 4 with the remainder of 1, 2, 2 with a remainder of 0, 2, 1 with a remainder of 0. So to get the binary, I should start from here. I'll go like this. So what is my binary expression? 1, 0, 0, 1, 0, 1 to the base 2, right? So in this way only we have got this expression. For example, the binary equivalent of 0 is 0, 0, 0. Binary equivalent of 1 is 0, 0, 1, and so on. Okay. Now, to obtain a Karnaugh map, we can obtain the Karnaugh map from the truth table, or we can also obtain a Karnaugh map from an expression. Okay, so I've taken the same Karnaugh map here, right? So from this Karnaugh map, from this truth table, how do I obtain a Karnaugh map? So the steps involved are: take the largest number. What is the largest number in this case? The largest number is this last one, which is 7. Find out its binary equivalent. What is the binary equivalent of 7? 111, right? Check how many bits are needed to implement the largest number. So for implementing 7, I need 3 bits. Obtain a Karnaugh map based on that. So take the largest number, find out its binary equivalent, find out how many bits are needed to represent the largest number, and then you find out the Karnaugh map based on that. So there should be some types of Karnaugh maps. The types of Karnaugh map are a 2-variable Karnaugh map, a 3-variable Karnaugh map, 4-variable Karnaugh map, 5-variable Karnaugh map, and so on. And one more important thing, the gray code is used in the Karnaugh map. Normally we use the binary, but here we are going in Karnaugh map, we are using the gray code, where every successive number differs by 1. Okay, so first we'll start with the 2-variable Karnaugh map. I have taken two variables A and B, right? So I'll write this as 0, 1 and 0, 1. Okay, 0, 1 and 0, 1. Now, this box will be 0, 0. And this one will be 0, 1. This one will be 1, 0. And this will be 1, 1. What is the decimal equivalent of 0, 0, 0? Decimal equivalent of 0, 1 is 1. Decimal equivalent of 1, 0 is 2. Decimal equivalent of 1, 1 is 3. Okay? A three variable Karnaugh map. So here A, B, C are the variables. Okay? So first I'll put 0, 1 here. This will be 0, 0, 0, 1. You will be tempted to put a 1, 0 here, right? But that's not correct. We are going for a gray code. So it should be 1, 1, right? And then 1, 0. Okay. So in the first box, what will I have? 0, 0, 0. Here it will be 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, and 1, 1, 0. Now, what are the decimal equivalents of them? 0, 0, 0 is 0, 0, 0, 1 is 1, 0, 1, 1 is 3, 0, 1, 0 is 2, 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 1 is 7, 1, 1, 1, 1, 0 is 6. Now for a 4 variable Karnaugh map. For a 4 variable Karnaugh map, again 0, 0, 0, 1, 1, 1, 1, 0 here, and it will be 0, 0, 0, 1, 1, 1, 1, 0. So this will be 0, 0, 0, 0 is 0, 0, 0, 0, 1 is 1, 0, 0, 1, 1 is 3, 0, 0, 1, 0 is 2, 0, 1, 0, 0 is 4, 0, 1, 0, 1 is 5, 0, 1, 1, 1 is 7, 0, 1, 1, 0 is 6, 1, 1, 0, 0 is 12, 1, 1, 0, 1 is 13, 1, 1, 1, 1 is 15, 1, 1, 1, 0 is 14, and here 1, 0, 0 is 8, 1, 0, 0, 1 is 9, 1, 0, 1, 1 is 11, and 1, 0, 1, 0 is 10. If you work it out, you can understand how we have got this exactly as in the previous tables. Okay, number of boxes in the Karnaugh map, right? I'll go to the two variable Karnaugh map first. How many boxes do I have here? This is my box 1, box 2, box 3, and box 4. Am I right? So in a two variable Karnaugh map, I have 4 boxes, right? In the 3 variable Karnaugh map, how many boxes would I have? In a 3 variable, 1, 2, 3, 4, 5, 6, 7, and 8, right? In the 4 variable Karnaugh map, I will be having 16 boxes, right? How are they related to twos? Right, the letter number 2. 4 is 2 power 2. 8 is 2 power 3. 16 is 2 power 4. So can I say that the number of boxes in the Karnaugh map will be the power of 2? For example, in a 2 variable Karnaugh map, right, the number of boxes will be 2 power 2. In the 3 variable Karnaugh map, the number of boxes will be 2 power 3, and so on. So in a 5 variable Karnaugh map, how many boxes will be there? 2 power 5. This is similar to what? This is similar to the rows in the 2 table. This is similar to the rows in the 2 table. If you go back and find out, you will understand that it is true. In a 2 variable 2 table, you will have 4 rows. In a 3 variable 2 table, you will have 8 rows, and so on. So the number of boxes in your Karnaugh map is related to the number of rows in the 2 table. Okay. Next, I have formed my 2 table I have formed a Karnaugh map. How do I form the groups? Make rectangular boxes containing total terms in the power of 2, like 2, 4, 8, etc. So a common mistake which most of the students do is they will try to form a box with 6 boxes. It is not right. Always you should form a box with either one element, two elements, four elements, 8 elements, 16 elements, and so on. That is, again, they should be powers of 2. Now, after forming the group, you should form the biggest group. Okay? And no element should be left uncovered. Okay? So, examples of grouping. Before going for the actual problems, we will some cases. We'll form the groups and then we will, when we go to the problems, that will be simpler. Right? Okay, so I have plotted all the ones in my Karnaugh map. I am assuming that I initially had a 2 table. From the 2 table, I have got the Karnaugh map. So I should group the ones because it is a sum of products simplification. I'll group the ones. If it is a product of some simplification, it's very simple. You should group the zeros. Okay. So this is one group and this is other group. I don't have any more groups. Am I right? Okay. How do I name my group? Examples of grouping and naming of my group. How do I name my group? For example, the red box consists of, okay, I'll put the names 0, 0, 0, 1, 1, 1, 1, 0. This is 0 and this is 1. I'll name the boxes, right? So 0, 1 and 1, 1. So look at the red box first. The red box, for the red box, I'm taking the red box alone, right? For the red box, A is equal to 0, am I right? And BC is equal to 0, 1 and 1, 1, right? So for both the boxes, A is 0. So I should choose the variable which is common to all the boxes in the group. You have to take this in your mind. You should choose the variable which is common to all the boxes in the group. Okay, so A is common to both the boxes. BC, out of BC, which is common? C is common. Am I right? B is 0 here, 1 here. I cannot take B. So what will be the name of the red box? The name of the red box will be A is 0. So I should write that as A dash. C is 1. I'll name this as C. Am I right? Take the next case, the green box. For the green box, if you see, A is 0 and A is also 1. So A is not common. I can disregard A. Am I right? So now BC. BC is 0, 1 here. Right? So BC is common for both the boxes. So I can close my eyes and take BC. Am I right? So BC, I'll go to the green box directly. What will be the green box? B is 0. So it will be B dash. C is 1. It will be C. That's it. We'll do another example. We'll take another. These are pre-plotted, but remember, for the examinations, you should plot the Karnaugh map first and then you should do, which we will do in the next video, right? Here, I have already plotted and this is a 4-variable Karnaugh map, right? Now I should form the groups. So remember, I should always form the group which has the largest number of elements, okay? So I'm going to do something. I'll take a green box first. This is it. I'll take a red box next. This is it. Right? But this is not right. Why is it not right? I'm plotting the same thing again. Right? I'll take the green. This is my green. Sorry, red. I can't do. Sorry, I'll take the same thing because okay. I'll take my green. I'll plot this here. Right? We can't do anything more. Whereas I'll take my red. The red can be this much. Am I right? Is that clear? So here, in this one, my red box had only 2 groups, 2 boxes. Whereas here, my red box has 4 boxes, which is right. The second one is right. that clear? So now for naming the boxes, I'll take the green box first. The green box, yeah, I'll take the green box. The green box, I'll project it row wise. A is common, B is not common. Am I right? I'll project it column wise. Here C is not common, whereas D is 1, D is 1. D is common, right? For my green box, what will be the name now? A is common and A takes the value of 0. So it will be A dash. And D is common and it takes the value of 1. So it will be D. Now for my red box. In my red box, A, B changes from 0, 0, 1, 1. B changes from 0, 1, 1, 0. So A and B cannot be common for all the boxes. Whereas when I project it up, for both the boxes, I have what? C is 1. For all the 4 boxes, C is 1 and D is 1. So it is common for all the 4 boxes. So I can close my eyes and take CD. Now, C is 1, D is 1. So what should be the name of my box? C is 1, D is 1. So CD. So what is the combined name? What is the final expression? I should take both. A dash D plus CD, right? So in this, I'll take the red box. The red box has 4 ones. Am I right? It is called a quad. The green box also has 4 ones. It is called a quad. When you take the previous example, yeah, in this example, the red box has 2 boxes. Red group has 2 boxes. So it is a pair. So I've seen the pair, we have seen the quad, and what can be the next one? Octet. Octet will have 8 boxes. Is that clear? Okay, so I'll come to this exam. I'll come to another example over here, right? Yeah, in this one, we have to form the groups. There is another way of, for example, there is 1, 1, 1, 1 here and 1, 1, 1, 1 here. They are not neighbors as far as you are concerned. But the Karnaugh map over here can be taken as a sheet of paper. Am I right? Sheet of paper. So you can roll this Karnaugh map, okay, which will make the first row to be neighbor with the fourth row. Am I right? In this case, all the neighbors were obviously seen, they were close. But here, the first row is neighbor to the last row. How? You are assuming the whole Karnaugh map to be a sheet of paper. So when you roll it, right, the first row will be neighbor with the fourth row. Am I right? So all are ones here. So I can combine this one with this one. Is that clear? Now I think you would have an idea in this one, and 2 ones are left here. Can I form a group? No. I should form a biggest group. So what can I do? I can combine all these together. So I have 2 groups, a red group and a green group. What is the name of the red group? And in the red group, how many boxes are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 boxes are there. It is an octet, right? Depending on the number of boxes, we can, if there are only 2 boxes, we call it as a quad. 4 boxes, we call it as a, sorry, if there are 2 boxes, you call it as a pair. If there are 4 boxes, you call it as a quad. 8 boxes, you call it as an octet. Right, now for the naming part. This I'll take this one. Yeah, this and this row and this row. What is common? A is no, A is 0, A is 1. A is not common, but B is common. B is 0 and B is 0, right? So I can take B. So one element for this red group is B dash. Am I right? And I'll project it column wise. Here, 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 here. Definitely, as it is evident, no column can be same because C is 0, 0, 1, 1, not common. D is 0, 1, 1, 0, not common. So what is the name of the red group? The name of the red group is B dash. Okay. I have another group, the green group. What is the name of the green group? Again, project the green group row wise. Obviously, A and B cannot be common, right? Project it column wise. What is C, D? C is 1, D is 1. It is common for all the 4 boxes. So what is the name of the green group? The name of the green group is C is 1, which is C. D is 1, which is D. What is the combined name? The combined name is B dash plus CD. Okay. What do you observe from all these cases? In a octet, we have only one variable. For a quad, you have 2 variables. For a pair, we have how many? For a pair, we'll be having more variables. Okay, so if you have a pair here, here it doesn't make sense because it is a 3 variable map and these are 4 variable maps. So as the size of the box becomes bigger, I'll write it here, as the size of the box becomes bigger, what can you say? The number of variables will be less. Is that right? So we are going for miniaturization. We want the number of variables to be less. That's why I said always choose the biggest group. Okay. Now we'll come to this one. Another form of grouping here, right? Here I'll consider this. I have a 1 in this corner, in this corner, in this corner, in this corner. So what did I say? I can assume this as a sheet of paper. I can roll from top to bottom. Similarly, I can also roll from left to right or right to left. Am I right? When I roll from top to bottom, the first row and the fourth row will become neighbors. When I roll from right to left, the first column and the last column will become neighbors, right? So if I form a red group here, this, all of them are neighbors. Is that clear? Right. So all the 4 corners, they have become neighbors now. What is I'll take my blue pink pen again. Row wise, I'm projecting. What is common? A is 0, 1. B is common. B is 0, right? So red group 1 name, B is 0. B dash. Come to this end. A is projected column wise. A is 0. Sorry, I forgot to write the name. This is CD. Right. C is 0, C is 1, not common. D is 0, D is 0, it is common. When a variable is 0, it should be taken as dash. So what's the name of the box? B dash, D dash. Is that clear? And any more groups to be formed here? Yeah. I can combine these 4. I can form a group. Obviously, the name of the group will be what? This one, you could project it here. Definitely nothing from AB is going to be common. Whereas when you project it column wise, C is 1, D is 1 is common for all the 4 boxes. Am I right? So C is 1 means C, D is 1 means D. So what's the name of this group? CD. Have I left out? Is my problem complete or have I left out anything? Yeah, a 1 is over here. What should I do? I should try to form the biggest group with this one. The only group which I can form with this one is I can form a black group, right? It is a pair. What is the name of this pair? I'll again take my pink pen. I'll project it here. A is 0, B is 1. It's the same for both the boxes in the group. I'll project it column wise. In this column, C is 0 and C is 1. They are not common, whereas D is 1. It's common. So what will be the name of this black group? Black group will be A dash B D. Am I right? How did I get this name? I'll repeat it again. This I am projecting it row wise. A, B. A is 0, B is 1 is common for both the boxes. I'll project it column wise. In the column C is 0, C is 1. It is not common. D is 1. So D is 1 means A dash B D. What's the final expression? Final expression will be the sum of all the three. It will be A dash B D plus B dash D dash plus C D. Right? So all the three are found here, right? We have a pair here. The black box is a pair. Pair A dash B D. How many variables are there? For the pair, I have 3 variables. For a quad, how many variables do I have? For a quad, the green and the red are quad. I have 2 variables. Obviously, when I go for an octet, I'll have only 1 variable. Is that clear? So all these things were related to sum of products. Next comes my product of sums. What is the difference between sum of products? So we have products, right? We formed a sum out of all these things. The next one is the product of sums. As you have learned, this pi stands for product. So what is pi? It's completely the reverse of sum of product. There, when a variable was 0, we took it as A dash. When a variable was 1, we took it as not true. We took it in its true form. Here, it's just the reverse. When a variable is complemented, we take it as 1, and when a variable is not complemented, we take it as 0. So 0, what is the binary equivalent of 0? 0, 0, right? 0, 0. In the case of sum of products, we took it as A dash B dash. In the case of product of sums, if the number is 0, the variable will be true form. It will not be complemented. Similarly, what is the binary equivalent of 1? 0, 1, right? So x is 0, y is 1. In the case of sum of products, how will we write it? We'll write it as A dash B. Am I right? Sorry, I'll use the same variables for you to understand. Yeah, I'll write it as x dash y. Yeah. In the case of product of sums, how have you written it? It will be written as x plus y dash. If there's a mistake over here, that will be x plus y dash. A 0 is taken as true variable and a 1 is taken as complemented variable. What is the last one? The last one is 2. What is the binary equivalent of it? 1, 0. How will you write it in the sum of products form? X, y dash. In the product of sums form, how would you write it? X dash plus y. Is that clear? Okay. Now we will see the general structure again. And then we'll solve a problem. General structure of pos. So as we did before, it's a 2 variable function, 0, 1, 0, 1. Right? So as I said, when a variable is 0, we take it as a true form. When a variable is 1, we take it in the complemented form. Okay? So 0, 0. How do I write it? A plus B. Here, what does this box correspond to? 0, 1. 0 is written as A and 1 is written as B dash. Slightly confusing, but you will come out of it. Remember, in sum of products, if the number has 0, that will be taken as complemented form. In product of sums, if a variable has 0, that will be taken in the true form, right? Now, what is this box? This box, A is 1 and B is 0. So A is 1 means A dash. B is 0 means B. What about this box? A is 1 and B is 1. So both will be complemented. A dash plus B dash. Am I right? Next, a 3 variable Karnaugh map. We are going to do it. What is this box? 0, 0, 0. How do you write that? A plus B plus Z. A0, 0, 1. A plus B plus C dash. Here it is 0, 1, 1. So A plus B dash plus C dash. 0, 1, 0. So A plus B dash plus C. Okay, here what is it? 1, 0, 0. So A dash plus B plus C. This is 1, 0, 1. So A dash plus B plus C dash, right? Here this is 1, 1, 1, which is nothing but A dash plus B dash plus C dash, right? 1, 1, 0. So this is A dash plus B dash plus C, right? Yeah, sorry, someone. Yeah, this is how we write the three variable Karnaugh map, right? Now, I have given a problem here. Solve f of a comma c is equal to pi of 0 comma 3 comma 5 comma 6. So as I did in the previous one, right, we will write the simplifications for what is 0 in the pos form. 0 is, I have a, b, c as the variables. So a plus b plus c. What is 3 in the pos form? 3 is, decimal equivalent is 0, 1, 1. So it will be a dash plus b plus c. What is 5? 5 is 1, 0, 1. So a plus b dash plus c. Sorry, I made a mistake here. What is 5? 1, 0, 1 will be, 1 will be taken as a dash. Am I right? Yeah. A dash plus B plus C dash. And what will be 6? 6 is 1, 1, 0. 1, 1, 0 is A plus B plus C dash, right? Yeah. Now we have to put zeros for all of there. In the case of sum of products, we plotted 1 for the numbers which were given. Here you should plot zeros for the numbers which are given, right? Yeah. So, yeah. So, 0, A plus B plus C. Where do I plot here? I'll plot this as 0. Just, I'll plot this as 0. And wherever I have a 3, I should plot that as 0, right? So, this is a 0. This is a 0, right? And 5. This is a 0. This is a 0, right? Now for the grouping part. How do I group? Yeah, how do I group? Here we cannot group anything because everything is isolated. So this is one group, this is another group, right? This is another group, and this is another group, right? So we'll write the sum of products and product of sum separately. If it is SOP, sorry, since we are doing POS first, we'll do POS and then we'll write POS here, right? So what is the green? What is this one? What does this one correspond to? That is equivalent to A plus B plus C. And what does this one correspond to? A plus B dash plus C dash. What is this one? This one is A dash plus B plus C dash. And what about this one? That is A dash plus B dash plus C, right? In the same way, if I have to write the pos form, it will be just the reverse, right? So after forming this expression, what is the final expression here? Yeah. What will be the final expression here? This will be A plus B plus C. Remember, it is product of sums into A plus B dash plus C dash into A dash plus B plus C dash into A dash plus B dash plus C. Okay. Now, the last part in my lecture in this video will be implementation. Right? I'll expand it right. Yes. Last part will be implementation. Oh, it's not expanding. Right. Yeah. Implementation. How do I implement it? I need to implement using gates. Right? So A plus B plus C. I need OR gate. Am I right? So I'll draw my gates. I'll draw my this things first. I need a A. I need a B. I need a C. Right? I also need A dash. I also need B dash. I also need C dash. Am I right? Okay. So this is my A, this is my B, and this is my C. I'll put a NOT gate here, another NOT gate here, another NOT gate here. So what will they become? This will be A dash, this will be B dash, and this will be C dash, right? So A plus B plus C. A from here, I'll take a line A, right? B8 plus B plus C. What gate do I put here? I'll put an OR gate. I'll put an OR gate because it is A plus B plus C. What's the next one? A plus B dash plus C dash, right? I'll choose my line again. A plus B dash plus C dash. Okay. I'll put an OR gate over here. So what is this? A plus B plus C. What is this? A plus B dash plus C dash. What's the last term? What's the next term? A dash plus B plus C dash, right? I'll A dash plus B, A dash plus, yeah, A dash plus B plus C dash. Am I right? I'll remove lines. I'll put an OR gate here. So what is this? It is A dash plus B plus C dash. What's the fourth one? A dash plus B dash plus C. A dash, I need to extend my lines further. A dash plus A dash plus B plus A dash plus B dash plus C. A dash is here, B dash is here, C is here. Okay, now I'll put an OR gate over here. Is my problem complete? Is my implementation complete? No, I still have to find the product. To find the product, I'll connect a AND gate at the output. Okay, I'll connect an AND gate at the output. Yeah, I'll put an AND gate at the output. I'll take all the lines, this line, this line, this line. Yeah, this line and then here. Here again, this one, and this one, and this one. Right, this one, here, and here. Okay, so what is my output now? My output, I'll take this as y is equal to, right? I'll take this as y is equal to. So what is this expression? Y. It is A plus B plus C into A plus B dash plus C dash into A dash plus B plus C dash, right? So we have completed whatever we have seen. Implementation is done. I'll meet you with another video soon in which I'll exclusively concentrate only on problems, right? Based on all these things, simplification of Karnaugh maps, implementation, etc. Right? For now, it is bye. Study well. Good night.